Okay guys, so today we're going to solve the problem balanced binary tree. So the problem says given a binary tree, determine if it is height balanced. For this problem, a height balanced tree is defined as a binary tree in which the left and right subtrees of every node differ in height by no more than one. Okay, so that means that a balanced binary tree is basically the one in which the left subtree and the right subtree and the difference should be not less more than one. Okay, so in this case, the height over here is 1 in the left subtree of 3, and the right subtree of 3, the height is 2. So, subtracting it, 2 minus 1 gives us 1. So, yeah, so this is a balanced tree, and all the trees, so all the subtrees should also be balanced. So, like here, 20 has 15 and 7, so has 1 and 1. So, the length height from the left subtree is 1, and the height from the right subtree is 1, and subtracting them, you get 0, which is not more than 1. So, all the nodes should be balanced, then it can be called as a balanced binary tree. Okay, so how we'll solve this is, okay, so let's create a function called check and put the root and root, yeah. Okay, now what we're gonna do is basically is check if it's none or not. Root is equal to none, return 0. Okay, now what we're gonna do is we're gonna iterate, we're gonna go through the leftmost part of the subtree, so 3, then 9, and then if 9 had any left part of its tree, then that. So first we're going from 3, then 9, then it'll be like left is equal to check root dot left. Okay, and we're gonna go, yeah, we're gonna do that. Now on reaching 9, then we're gonna go to 9's left part. On reaching 9's left part, we'll get nothing, so we'll return a 0. Okay, and in left we'll return a 0 plus 1. Okay, so 9 will get a value of 1 over here. Okay, similarly we'll do it for the right portion too. Let's check root dot right plus 1. So now when we go to 3, then 9. Okay, the 9's leftmost node, so 9's leftmost node will give us a value of 0, and we'll return it with a value of 1. So 9, so we'll return it with the value of 1 over here, 0 plus 1 1. Now when we go to 9's rightmost part, we'll again get a 0, and after getting a 0, we'll do a 0 plus 1 and 1, we'll return 1 again. So 9's right portion will give you a value of 1, and left and right both will give you a value of 1. Now you have to check the absolute value. So if absolute value of left minus right is more than 1, then we'll just return something like infinity, float of inf, and if it's not greater than 1, then we'll return the maximum value between left and right, left comma right. Okay, so okay, let's run the code. Oh no, sorry, I forgot. Yeah, we have to also return self dot check, and we'll just check if it's infinity, or not. If it's infinity, then we'll return a false, and if it is, then if it isn't, then we'll return a true. Okay, now running it. So what's that? Okay, so let's do this. Self. Okay, and run. Now what? CHECK. Oh, okay. Self.check of root, and running it. Oh my god. There's no attribute check. Oh, okay, yeah, this should be here. Oh my god, so many typos today. Sorry, guys. Not typos, mistakes, silly mistakes here. And it's yeah, so we got the answer and submitting it. Yeah, it's submitted. Okay, so what we're doing here is, so let's take an example. Let's take this example. So we're gonna go to the right portion of 9. So we're gonna put the root in 3. We're gonna uh, go through its leftmost part of the subtree. Go to 3, then 9, the 9's left and right. So if we reach 9, 9's left will give you his value of 0 plus 1, plusing 1 with it, so we'll get a value of 1 from right, and its right will give us a value of also of 1. Okay, so now 9 has a value of 1 and 1 from its left and right. Now taking the absolute value, since 9 left minus right is less than 0, because 1 minus 1 will be 0, then we'll just return max of left and right. So the max is 1, so you can take 9 with a value of 1 now. So 9 has a value of 1. Okay, so 9 over here has a value of 1. Now we go to the right subtree. On going to the right subtree, we go to 20, and then we go to 15. Now when we reach 15, we get a value of 0 and 0 from both the sides. Okay, 15 gives you a value of 0 and 0, and when you return that value from 0 and 0 to 15, you get a value of 1. So 15 gets a value of 1 from left and right. L, yeah, 1, and R gives you a value of 1. Okay, now taking the absolute value, subtracting it, so it's 0, and taking the absolute value, sorry, the maximum value, which will be 1. Okay, now we go to 7. On going to 7, you check the left subtree has 0 and right subtree 0, so you'll get a value of L plus 1, which is 1, and R plus 1, which is 1. Okay, and the maximum values, because after checking this, we get the maximum value, which is 1. Okay, now we go to 20. Now 20's left has a value of 1 and 20's right has a value of 1. Now they both will give it a value of 2. Okay, on giving it a value of 2, so 20's left would be a 2, because L plus 1, so its L is 15, which has a value of 1 now. So under giving it the value forward to 2, so 20 will give you 2 on left, and right would give you also 2. Okay, so the absolute value of 20 is maximum value, sorry, will be 2, and which we'll assign to 20. So the value of 20 is 2 and the value of 9 is 1. Now 3 will get a value on its left as it will get a value of we'll check first if 2 minus 1 is 1. Okay, so if it's 1, we return the max, which is 2, and on returning the max, we basically just get a value over here, which is 2 plus 1 3, because we return 2, so we get 2 plus 1 3 over here. So 3 gets a value of 3, and so you can just check if it's not infinity. So the root currently is not infinity, so we get a true value. And yeah guys, that's how you solve the problem. And if you like the video, please do like, share and subscribe, and I'll see you guys in the next video. Thanks.